Hi, I'm Hadley Pinder, and I'll be doing number 1. So, person says, which of the terms describes or is an example of a regulatory protein? So we know that would be a repressor, an activator, and the CAP. Then part B says, which of the terms describes or an example of a small effector molecule? So that would be a lactose, which is an example of a inducer, and then CAMP and an inhibitor. And which of the terms describes that question, I can't read that. Example of a sequence found within DNA. The +1, -10, the operator, the lac. A, seriously. And then the lac Z. And did I say operator already? I don't know. Which of the above is not involved in the lac operon? So for this one, we said that everything was involved in this system, so we were going to say none of them. Which of the above is an example of a structural gene? The only two that are genes are the lac A and the lac Z.
Oh, you're turning it off?
No.
Jesus Christ.
Oh, all right, I'm Tyler, gonna do number 2. It's fill in the blanks. So, part A says the lac operon is regulated by 2 inducers, and that's lactose and CAMP. Part B, the binding site for sigma factor in RNA polymerase is called the LACP, while the CAP site is the binding site for the activator that regulates the lac operon. Part C, so it's an enzyme, adenyl cyclase, converts ATP to cyclic AMP. Part D, the -35, -10, and +1 sequence are found within the LACP portion of the lac operon. The LAC-I gene encodes for the, or is it L?
LAC-I?
It's LAC-I, yeah, okay. Encodes for the lac repressor, while the LAC-Y gene encodes for lactose permease. F, attenuation can regulate gene expression in bacteria by causing transcription to terminate prematurely. G, an E. coli strain that contains 2 copies of the lac operon is called a merizygote strain.
Sorry. So I'm Christina Cross, and I'm going to be doing number 3, examining the lac operon in E. coli. In your experiment, the activity of the enzyme B galactosidase is measured by including X-gal and IPG in the growth media. IPG can mimic lactose. IBTG can bind to the lac repressor and release the repressor from the operator. Then X-gal is a molecule that is a substrate for B-galactosidase and turns the E. coli cells blue when metabolized by B-galactosidase. So they're just going to ask you different scenarios, part A through E, and they're asking if it's going to be blue or not. And for A, IPTG is absent, glucose is absent, and X-gal is present. And that's going to be no, because with glucose absent, CAMP levels are going to be high. So the CAP does bind to the CAP site, but the repressor is not bound due to the absence of IPTG. So expression doesn't happen. And then for B, IPTG is present, glucose is absent, and X-gal is present. So it is going to be blue because with IPT present, the lac repressor is released. And with glucose absence, CAMP levels are high and CAP binds to the CAP site. So it can happen. So there is blue. And then for C, IPTG is present, glucose is absent, and X-gal is absent. Because XGAL is absent, even if everything is, if they have the right environmental conditions, there's going to be no expression. So it's going to be no. And then for D, IPTG is present, glucose is present, and XGAL is present. So that's going to be no due to the low levels of CAP. The CAP site does not bind to the CAP. So it's not going to be blue. And then for E, IPTG is present, glucose is present, and XGAL is absent. It's also going to be no because, again, XGAL is absent, so there's going to be no expression.
Oh, there we go. The scroll on this. Okay.
Sorry.
I'm Donovan Wixom, and I'll be doing 4. So for part A, everything I plus, P plus, O plus, and Z plus, that means everything is working good, which means that it is inducible because that's the normal state of the operon. For B, we have IS, and then P plus, O plus, and Z plus. IS means that the repressor is going to bind to the operon and not let go, so it'll never function, so it's non-inducible. For C, on the chromosome, we have I plus, P plus, OC, and ZC, or Z plus, sorry. And then on the plasmid, we have the same, no, just kidding. We have I plus, P plus, OC, and Z plus. So because of the OC, the repressors are never going to bind to either the plasmid or the chromosome. So it's going to constantly be going, so it's constitutive. On D, we have I plus, P plus, O plus, and Z plus. So that's going to function normally, except that we have IS, P plus, O plus, and Z plus on the plasmid. So that's the one we have modeled here. The IS is going to produce repressors that bind to the operon and won't let go. And they're not only going to bind to the plasmid, they're going to bind to the chromosome as well. So neither of them are going to work, and it's non-inducible. And for the final one, we have IS, P plus, O plus, and Z plus. And then on the plasmid, we have I plus, P plus, OC, and Z plus. So normally, the IS would mean that, again, the repressor would bind to the operons on both of them, and neither of them would work. But on the plasmid, we have OC, which means that the repressor can't bind ever. And so that one's always, the plasmid's always going, and it's constitutive.
Hello, my name is Riley Wilkerson. I'll be working on number 5. So number 5, we have, scroll. He gives us a chart of different genes, and it's just like number 4, where it gives us, so for A, we have I negative, which means it doesn't work, O plus, P negative, Z plus, Y plus, and A plus. So because our I never works, it's never going to bind. And so it's just going to keep on making proteins, even though if there's no lactose involved. So it's always going to be yellow, because yellow means that we have proteins that, well, lactase. For B, we have I plus, OC, P plus, Z plus, Y plus, A plus. The OC means that that's never going to bind to the operon, which means that it's also going to just keep running as well. So we're going to have one yellow, one yellow. For C, this is where we have a chromosome and a plasmid. For the first one, we have I plus, O plus, P plus, Z plus, Y plus, A plus, which means sounds completely normal. And then for the plasmid part, we have I plus, OC, P plus, Z plus, Y plus, A plus. So the OC is going to make it so that the plasmid is, well, that the that our reducer is not going to, repressor is not going to bind. And so it's going to just keep making our protein, even if there is any lactose involved. But because we have also a normal one up top, when we do add that lactose, both of them are going to be running smoothly. So that's why we have 2 yellow when there's lactose and 1 yellow when there's no lactose. For D, we have 1 yellow for lactose because we have I minus, O plus, P plus, Z plus, Y plus, A plus for our chromosome, and then I plus, O plus, P minus, Z plus, Y plus, A plus. And because we have a promoter that doesn't work, that one, the plasmid is not going to create proteins, so it's not going to turn yellow. But the chromosome is completely normal except for the I, but the I from the plasmid is going to affect the one from the chromosome, thereby making it act normal. So when lactose is present, it's going to be a 1 yellow, but when there is no lactose, it's going to be 0 yellow. And then for E, we have I minus, and then everything's works fine for the chromosome. And then for the second one, we have IS, and everything's normal for the plasmid. And the IS is going to constantly bind to the chromosome and the plasmid. And the IS binding to the chromosome and the plasmid is going to stop the production of proteins in both the chromosome and the plasmid. So we have 0 proteins, 0 yellow, and 0 yellow for both of those. Thanks for watching.